Hello, my name is Manoj Verma and I am from Mumbai, India. I have more than 30 years of teaching experience in chemistry. I'll be teaching you the AS and the A level of chemistry in a very simple language and easy to follow. And I expect that you will follow my lectures and be able to prepare well for your exam. Thanks a lot. So today I'm going to discuss some numerical problems which I have taken from the equilibrium chapter of the AS level, and I'm going to refer to some of the past papers to help you understand the kind of questions which are asked. So are you ready? So let's begin with the lecture and start with the equilibrium questions. Okay, so now I'm opening the questions which I have taken, so the PDF. So this is what you see here, and so you see that there is this AS level past papers, that is from the equilibrium topic, and the first question that I have taken is from the the May June 2008 paper, and that is the paper variant 2, and it's an equilibrium question. Okay, and now if you read the question, it is that uh, NO is also formed when nitrosyl chloride dissociates according to the following equation. So this is nitrosyl chloride dissociates and NO is formed as one of the products along with chlorine. All are gaseous. Different amounts of the three gases were placed in a closed container. You should know that the container is closed because then only an equilibrium can be established. And allowed to come to equilibrium at 230 degrees Celsius. The experiment was repeated at 465 degrees Celsius. And now they have given you a table in which there are two different temperatures, 230 and 465, and at these temperatures what are the concentrations of NaCl, NO and Cl2. They are given in moles per dm cube at 465. The concentrations are different. They have been experimentally found out and these values have been given to you. Now let us look at the first question. The first question says that write the expression for the equilibrium constant Kc for this reaction. Give the units. Now you are well aware, if you have just read this chapter, that when we write the formula for Kc, the concentration of the products is taken in the numerator. So the products are NO and Cl2, and this bracket means the concentration. And then this 2, which is the coefficient for NO, goes as the power. So the concentration of NO square into the concentration of chlorine, here 1, so no need to write any power. Then divided by the concentration of the reactant, which is NaCl, and then this coefficient 2 goes as a power. So this is the expression for Kc. So you can see here, this is the expression for Kc. Okay, now what about the unit? Calculate and write the unit. So for unit you should know what is what's the unit for concentration. The unit for concentration is mole dm raised to minus 3, or mole per dm cube, and it is a square, so write the unit and do the square. This is only once mole per dm cube. This is once again the concentration square, so write the unit of concentration square. This gets cancelled and what remains is mole dm raised to minus 3, and that is the unit for the Kc, mole dm raised to minus 3 or mole per dm cube. So I think you understood this. Now the next question is that calculate the value of Kc at each of the temperatures given. So you have to use this formula and put the values once for 230 and the second time for 465. So at 230 these values you will put, and at 465 these values you will put. So if you look at the solution, and you can just compare that at 230 NO is this, this NO is this, Cl2 is this, and NOCl is this, and they have put the values and solve. You get the value of Kc, and the value of Kc that you get is, as you can see, it is 4.5 into 10 raised to minus 3. That is the value. And then when you find the value at the other temperature, that is at 465 degrees, then you take these values, right? And then you put the values here for 465, and then just put the values and solve, and you get 9.2 into 10 raised to minus 2. The unit anyway is mole per dn cube, so you have written the unit here. Now look at the next question now, and the next question says that is the forward reaction endothermic or exothermic? Explain your answer. So how you are going to decide? What you have to see is that as you raise the temperature, the value of Kc increases. You can see this. This is 10 raised to minus 3. This is 10 raised to minus 2. So value of Kc increases. If the value of Kc increases, that means there are more of the products. There are more of the products. So if there are more of the products, it means that the equilibrium has been shifted towards the right. Correct? And if under what conditions is the forward reaction shifted towards the right? It is the endothermic reaction. Because if it is exothermic reaction and then if the temperature is raised, the equilibrium shifts towards the left. Therefore, the value of Kc would decrease. So, the increase in the value of Kc at the higher temperature clearly indicates that this reaction is endothermic. So, that is the answer. The reaction is endothermic. Now, let us look at the next part. The temperature of the equilibrium was then altered so that the equilibrium concentrations of NaCl and NO were the same as each other. What it means is that if you see the concentration of NaCl and NO are different. See, in both the cases they are different, but maybe there is some temperature in between this where the two concentrations become equal, and of course chlorine concentration will be different, but these two concentrations are equal. So the temperature of the equilibrium was altered so that the equilibrium concentrations of NaCl and NO were the same as each other. What will be the effect on the equilibrium concentration of NaCl when the changes are carried out on this new equilibrium? In each case, explain your answer. So the first situation is the pressure of the system is halved at the constant temperature. So the pressure is halved, that means pressure is reduced. So the pressure is reduced. So what does the Le Chatelier principle say about that? If the pressure is reduced, see, if the pressure is reduced, correct? If the pressure is reduced, then equilibrium will try to increase the pressure. The equilibrium will try to increase because it will oppose. So to oppose the reduction, it tries to increase. So in order to increase, that means number of moles should increase. If the number of moles will increase, right, then obviously the pressure is going to increase. So it will oppose the reduction in the pressure. So now you have to look where the number of moles are increasing. So if you see here in the reaction, there are 2 moles of the reactants, but 2 and 1, 3 moles. That means 2 moles, 3 moles. That means that here there are 2 moles and here there are 3 moles. So the number of moles increases is in this direction. So the equilibrium will shift in this direction when the pressure is reduced. That means the amount of products will increase and the amount of reactant would decrease until a new equilibrium has been established. So let's look at the answer. So the answer is that equilibrium moves to the right hand side because there are more number of moles on the right hand side. I think you understood this. Now the last part of the question is that a mixture of NaCl and NO containing equal number of moles of each gas is introduced into the container at constant temperature. So now you are introducing from outside a mixture in which there are equal number of moles of NaCl and NO. So if you add equal number of moles, that means this ratio is going to be affected in the same way, right? So this will be affected in the same way, and therefore what is going to happen on the equilibrium concentration of NaCl? So obviously, because there are equal numbers and it's a form of a ratio, so there will be no change in the equilibrium position, right? Because the NaCl and NO change by the same amount. So I think you understood this. So we will solve the other questions at some other time. Come back to the channel and see the new videos, and you will be able to get better idea. If you have got any doubts or comments, please use the comment section to give your comments. Thanks a lot for watching.